everyone, and thanks for joining our webinar today. My name is Sue, and I'm a part of the education team at Medit. So today we'll look at the inlay treatment case that was scanned using Medit i600. The i600 is our new scanner that was released this year, and it already got a lot of good feedback from our users. With its nice blue body, fast scanning speed, and reasonable price, it is a great solution for many users. And here today with me is Dr. Kim, who will be my co-host. Doctor, thank you for joining us again.
Hi, Sue, and welcome everyone. Thanks for having me. It's already December. Wow, time flies. Thank you for this year, and I just want to wish our viewers warm and happy holiday.
Right, it's already, oh my God, it's already December. I believe that good things are on the way for 2023 for all of you. So let us begin then. Recently, we've got some requests for an inlay webinar from the users, and I was a little surprised because I thought the inlay case would be the easiest case, but oh boy, I was wrong. I guess I also have a lot to learn.
I see what you mean. Preparation for INA could be a little tricky because a lot had to be considered beforehand. For example, photo milling process or bonding. All these might affect the final inlay placement, so one must think about it in advance.
Exactly. It does sound trickier than it first seems, but I believe you prepared this webinar to help our users to overcome any difficulties, right? Like the last time, today we'll also have a Q&A session afterward. So if you have any difficulties while working on an inlay case, I hope you will find the solution during the webinar. And before we get started, I just wanted to mention that this webinar has been recorded and it will be available on our YouTube channel, Medit Academy, soon after the webinar ends. And if we don't manage to all of your questions right now, right this time, the replies will be sent to you via email. Doctor, so you're gonna start from the cavity preparation, right?
Yes, I will, because it's a good practice to consider one may affect the cavity preparation for the inlay to achieve the best result possible. Let's see the slide.
Right, see the slide.
Let's kick off today's lesson with CAD/CAM inlay cavity preparation, including cavity preparation design and bleeding control. In order to prepare a CAD/CAM inlay cavity, the following should be considered. First, minimally invasive preparation. Second, proximal box elevation. Last, consideration milling process. Let's take a look at the minimally invasive preparation first. Here is a study on the adhesive interface of ceramic inlays according to minimally invasive preparation, published in Operative Dentistry in 2022. As you can see on this slide, various marginal angles such as A, B, C can be found in the cavity. And additional tooth preparation in the blue areas of B3 and C3 is needed to give the conventional 90-degree marginal angle. As a result, if the margin is created avoiding central occlusion, the minimally invasive cavity designs such as B4 and C4 are accepted clinically. There are two ways to fill in the undercut area. Filling it using loading cement or plugging out with resin. First, let's look into the problem when filling it using loading cement. This paper shows a thick resin adhesive layer causes higher cusp deflection. Another paper, the influence of cement layer thickness on the stress state of metal inlay restoration, Said higher shrinkage stresses are associated with thicker cement layers. From the above, it is not appropriate to fill the undercut with resin cement. Therefore, complete the cavity with an appropriate block-out would be a good way to reduce the adhesive interface. However, you might be concerned that the resin will reduce the adhesion strength. According to this paper, it is better to use additional flow-over resin with a higher filler content rather than using a commonly used universal adhesive only, because the hydrophilic property of universal adhesive reduced the adhesion strength. See the delayed native sealing, the first one of DBA mode in the table, and it shows low adhesion strength to the contaminated result no matter which dentin bonding agent was used. And OBFL with a relatively high filler content shows the highest adhesion after immediate dentin sealing, regardless of the floral resin coating. However, IDS does not increase microtensile bond strength when using DBA with low filler content. Therefore, DBA with low filler content should be reinforced with a floral resin coating to increase microtensile bond strength in dentin bonding for IDS. This technique is referred to as reinforced immediate dentin sealing in this paper. So we can conclude that using resin to block out the undercuts can have a positive effect in terms of adhesion. Therefore, I highly recommend blocking out the undercut area using floral resin without additional preparation. In this way, the cavity cannot be enlarged, and surface treatment before impression taking can increase adhesion strength and solve the problem of the inlay ill-fitting. Next, let's see how to solve the problem in case of subgingival margin. The margin elevation is a technique to raise the subgingival margin about 1 mm above the gum using a resin as shown in figure C. There are a lot of benefits when using this technique, but it especially allows for easy scanning and is beneficial for moisture proofing when performing the bonding later on. And as I mentioned earlier, applying resin to the inlay cavity is not detrimental to bonding. Isolating the tooth with a double Meyer band and adding the resin layers until the margin is elevated above the gingival level to 1 to 2 mm. Once done, isolating the tooth with a rubber dam will be easier. Lastly, let's take a consideration the further milling process. The cavity should not have convex narrow areas. This is because machining cannot be performed if there is an area narrower than the machining tool size. For same-day treatment, you need to control bleeding, and the following will help. First, sonic handpiece. Second, rubber dam. Third, matrix band. Last, hemostasis. First up is the sonic handpiece. Sonic handpiece has 3,000 to 9,000 elliptical oscillations per second, so there is more horizontal movement. It helps minimize bleeding with less gingival irritation compared to high-speed rotating bolts, and you can prevent damage to adherent tooth. Currently, there are sonic flex from Cable and Progeo from WNH in the market. Partially diamond-coated tips can be used to protect proximal surfaces. A tip with the shape of the cavity makes it easy for the proximal box preparation. The second is a rubber dam. You can use a rubber dam to protect the gum from the instrument during preparation. It will slightly push the gingiva away from the burr, ensure no accidental damage is caused. Moreover, it is easier for the dentist and assist to work when the tooth is isolated from the cheek and tongue. As a dam prevents water from entering the throat, it also creates a more pleasant experience for the patient. The third is matrix band. To help isolate the case of gingival overgrowth during preparation, you can use a Doppelmayr band. Position the matrix band, push the overgrown gingiva out of the band, tighten the band. Additional cavity preparation. Here is one good tip to help to quickly stop bleeding. Applying hemostatic agent and waiting 2 minutes. Compress with gauze and wait an additional 2 minutes. Wash without too much force. Margins are sharpened by the additional retraction effect. We looked at the points to consider in order to perform CAD/CAM-enabled cavity preparation well. So I'm going to wrap up today's first lecture by showing you a video of preparation of the inlay cavity use reinforced IDS and deep margin elevation. I tweeted the method side caries of tooth number 47. Remove the caries roughly using a high-speed handpiece. You see the gum is in the cavity. If you pre-curve the wing of the sectional matrix and apply it to the proximal surface, you can make it fit the cavity by itself. Push the matrix and gingiva out of the cavity while touching the margins using a flat instrument such as a resin applicator. Completely remove caries. Apply the adhesive according to the manufacturer's recommended method and write curing. Exceed etching for 10 seconds for enamel and 3 seconds for dentin. Apply the adhesive and rub it for about 20 seconds. After drying, light cure for 20 seconds. Layering with flowable resin on the deep margin and light curing. Fill the remaining dentin surface, including the undercut area, with flowable resin and light cure. Remove unsupported enamel. Capture with i600 and prepare for inlay fabrication.
Now I know how users feel. And the technique of proximal box elevation seems quite useful. But I have a question, doctor. So you talked about building up resin layers about 1 millimeter and curing after applying each layer. So I wonder for how long you should cure about it.
Depending on the light power, the curing time will be decided. In general, if the light power is 1000 milliwatt per square centimeter, the curing time is 20 seconds for each layer.
Oh, I see. Thank you. So now that we're all set for the scanning step, let's hear about scanning with i600 and the following milling process.
Scanning with i600. You can save time by scanning while the patient is waiting for the anesthesia to take effect. At this step, we will be doing a pre-op scan or else called a study scan. It should be enough to scan just a quadrant with the tooth in question. First, scan the maxilla. There is no need to be meticulous at this step, but I would recommend scanning the gum area 7 to 8 mm away from the teeth when capturing the gum on the buccal side. This later would help to perform the occlusion alignment. Then scan the opposite quadrant in the mandible scan stage. Once done, move to the occlusion scan stage. First, to place the scanner tip on the buccal side of the posterior teeth while the patient's mouth is slightly opened, and then instruct them to close their mouth. After it, you can press scan and acquire data by moving the tip along the buccal side towards the anterior. To make sure you capture some gingiva, you can tilt the tip up and down. When the alignment is completed, add a scan stage for capturing the prepared tooth. In stage management, click on the pre-op for maxilla. Your previously scanned maxilla data will be automatically transferred into the pre-op scan stage. Using trimming to cut out data for the target tooth of your treatment. When the needed treatment is done and there is no bleeding, you can capture the prepared tooth. Thoroughly scan not only the tooth but also the gum area around it. It may be difficult to properly capture the proximal areas, so my tip here is to change the angulation of the scanner tip by slightly rotating the wrist. Trying moving the wrist so that the tip would move buccolingually. Designing in exocad. For ceramic inlay, I recommend using 3-axis milling. The 5-axis setup can leave undercuts in the design, which could later cause problems when fitting the completed inlay. There will be 3 major steps in the inlay design process: drawing the margin line, adjusting the inner surface, and designing the outer one. It is essential to set the insertion direction so that the inlay can be placed with the least obstruction. When creating the inner surface, give the angled parts of a bit of extra gap, because usually these parts tend to be less milled. So, to ensure a better fit of the milled inlay, try creating more space on the line angles of the inner surface at this step. Complete the inlay design by restoring the outer surface with consideration to the functionality and aesthetics. One common mistake here is creating the proximal surface too close to the adjacent tooth surface. Though the intent is to prevent food from getting stuck, in reality it makes removing the stuck pieces harder. So I recommend you ensure the surface design on the proximal side is point contact. There are 2 types of machines that can be used for milling a ceramic inlay. One is a ceramic milling machine and the other is the universal milling machine. We will talk about using the ceramic milling machine. First, import CAD files with the completed inlay design into CAM software. Choose the size of ceramic block. Position the design within the yellow boundary in the correct orientation for milling. Attach connector to the inlay design. I recommend using a conical shaped connector. If you choose a thick cylindrical shape, it will cover the prosthesis too much, but a thin one could break during milling. The tool path will be calculated once you choose a milling strategy. Then import toolpath file into the milling machine to begin. Milling time depends on the size of the case, but in general it should take between 10 to 15 minutes. The main advantage of using a ceramic milling machine is the high speed that is possible due to two spindles. It is also more precise thanks to the various size of bars.
I think it's good to know it all, even the milling and design process. So what steps are left, doctor?
Now I go over the surface treatment of a milled inlay and adhesion steps. Plus, I'm going to share my tips for using a rubber dam.
All right, then let's move on to the next slide.
Surface treatment of ceramic inlay. In ceramic, the ceramic network dominates 75% of the volume, and the resin network forms the remaining 25%. Ceramic is a hybrid material with a high concentration of ceramic components, so it must be etched with hydrofluoric acid to increase adhesion. A common recommendation from the manufacturer is to etch it with 5% fluoric acid for about 60 seconds. But I have seen research papers that recommended using 10% acid for 60 seconds. There is recommendation for using an ultrasonic cleaner for 60 seconds for safety reasons. It can also be good to use a steam cleaner at the end, after the connector is removed. Complete by polishing with an enamel designated polishing kit. If an enamel inlay is properly polished, the chance of the antagonist abrasion would be lower. It is obligatory to do the surface treatment with a silane coupling agent in the bonding of the ceramic inlay. Silane is composed of a functional group that combines non-organic ceramics and organic resin adhesives. Chemically, silane is not active until it undergoes hydrolysis. It requires a small amount of water and acid. Usually, ethanol is used as a solvent for silane. There are three types of silane in the market. One contains silane solvent, ethanol, water, and acid all in one bottle. But as the hydrolyzed state gradually decreases over time, the shelf life of such a mixture is about 6 months. And there might be two bottles, where one contains silane and ethanol and the other water and acid. These are then mixed and can ensure a more reliable effect. There is also an option when silane is included in universal bond, but it is not recommended because due to the unreliable effect. I recommend letting it dry naturally for about 1 minute, but you may also use any dental dryer. Saliva contamination can have a great impact on the salinization process. Therefore, it is better to apply fluoric acid and saline after the drying, or do the drying after applying both hydrofluoric acid and saline. If there is saliva contamination during the drying with only fluoric acid applied, the contamination must be eliminated with phosphoric or hydrofluoric acid again. However, if the drying is performed while the rubber dam is applied, the odor does not matter much. Using an unfilled resin adhesive after silane treatment has an advantageous effect on adhesion.
Thank you for sharing your secrets with us, doctor. Then let's move on to the Q&A session. As you know, we got some questions before the webinar, and now we'll answer them. But before that, I just wanted to remind everybody that this webinar is being recorded and will be uploaded to our YouTube after we're done. And if we haven't covered everything you need here, the answers will be sent to you after the webinar ends via email. Let's look at the first question.
I saw you are using i700 in another webinar, and I'd like to ask you if you have scanned an inlay case with i700. If so, is it that different? Basically, i700 is faster than i600, and there are some functions with i600, but the accuracy of the data is the same. So what do you think, doctor?
Yes, I'm using both i600 and i700 scanners in my clinic, and I've scanned the inlay case with both. Theoretically, the frame rate per second doubles, but it is difficult to feel the speed difference in the actual patient's mouth. And I think there is no difference in the accuracy of the data. However, sometimes I do need to use HD mode to capture narrow and deep area. And in those cases, I can use the i600 as it doesn't support the HD mode.
See the next question. Which material is the best for digital inlay restoration? Are there any materials you recommend? Doctor, you've already mentioned the material anemic during the lecture, but are there more?
There are many to choose from, as you can see on the slide: feldspar, lithium disilicate, hybrid resin, and PICN. Another point to consider is the position of the tooth being treated. Will it be anterior or posterior teeth? Then think about the strength, adhesion for the milling process, and aesthetic of the material. So I tend to use Mark II for anterior teeth and anemic for the posterior teeth.
Third question. I'm worried about the impact of inlays that use materials other than gold on the antagonist teeth. I understand what you're worried about, what this user's worried about. So, doctor?
Here is a research that reviewed the effect of simulated mastication on the surface roughness and wears of machinable ceramics and opaque dental enamel. According to it, anemic has the least effect on antagonists. That's why I prefer using anemic over other materials.
Next question. If the teeth state is okay for doing inlay restoration again after removing an old one, would you do it or would you prefer doing an only?
The prep area might get bigger if you treat cracks or caries, but it's better to keep it as it is to minimize the additional prep area. It can be done by block out the undercut areas using fluoride resin.
Let's see next. How long do digitally fabricated inlays last? Is there any difference compared to the conventional way?
In my personal experience, there is no difference between both methods. I searched for a paper to show you, and as you can see, the pressed method is superior in inner fit and material strength, but there is no significant difference in lifespan.
Next, I know HD scan helps to increase the data accuracy, but I forgot to use it most of the time when scanning the patients. And I think it's okay if I don't use it, but do you think is it needed? Do you use HD scan all the time? Let me briefly explain what HD mode is for those of you who are yet unfamiliar with it. So HD mode is basically a feature that captures the image in high resolution. So when you're scanning prep teeth or scan bodies that demand higher precision, this function will be useful. So doctor, do you use it all the time?
As mentioned in the first question, I'm using this function only when I'm capturing narrow and deep areas. Other than that, I don't use it.
Last question. Are there any other Medit features useful for capturing inlay cases?
I normally scan the pre-op data for capturing the accurate bite in the proximal contact points, shade or shape of the teeth, then scan the abutment teeth after the preparation. And when you can scan the abutment teeth, you can scan without using a trimming tool. Just start scanning from the adjacent teeth and add scan on the pre-op data. The software automatically recognizes and deletes the pre-op data. Quite interesting. Another useful feature is the one that allows recording the patient's actual mandibular movements. Using it, accurate dental restorations can be fabricated by taking into account the patient's mandible movement. As a result, occlusal adjustment of dental restoration in the patient's mouth can be minimized, which is beneficial for shortening chair time.
Okay, let us wrap up here. You can watch this webinar on our online training platform like YouTube or Medit Academy after we're done. And if you have any questions or feedback, please send an email to meditedu@medit.com. Dr. Kim, thank you again being here today. I hope we can meet in the next year too. And thank you for your hard work this past year and hope you have a happy holiday.
Thank you, Sue. I wish you a happy holiday too.
Thanks again, and thank you for everyone joining our webinar today. So we'll continue these webinars with Dr. Kim next year too. So see you in the next year. Bye.
Bye.